So I want to quickly go over Donders problems, but before we do, I wanted to give a little bit of context that helped me understand these problems better. So let's say we put an object 40 centimeters in front of, for this example, an emmetrope. We know an object at 40 centimeters has an accommodative demand of 2.5 diopters. And so an emmetrope, if we put something 40 centimeters in front of them, they would have to accommodate 2.5 diopters to see it. Um, but a myope uh, is a person who has an eye that's stronger than an emmetrope. So in this case, we have an uncorrected minus 250 myope, meaning their eyes has 2.5 diopters more strength than an emmetrope. In which case, if we put something 40 centimeters in front of them, they would not have to accommodate at all to see it. Um, a hyperope has an eye that's weaker than an emmetrope, in which case, if we put something 40 centimeters in front of them, they'd have to accommodate an additional amount to see that. So in this case, we have a plus 250 hyperope who needs to accommodate through their refractive error and an additional amount to see the object. So this person would have to accommodate 5 diopters. And finally, we have a corrected presbyope wearing a plus 250 add. So anyone corrected, like either a myope or a hyperope that's corrected, has their eye as the same strength as an emmetrope. So this patient has like the same strength as an emmetrope, but they're wearing a plus 250 add, which gives their eye additional strength. In which case, this patient would also not have to accommodate to see that object. You don't need to understand all that. The main thing you need to take away from this is this right here. So let's say we're performing Donders and the patient sees their first blur at 10 centimeters, which we know is 10 diopters. For an emmetrope or a corrected hyperope or myope, I just want you to do nothing. We can just convert the distance into diopters and accept it. So this patient, 10 diopters is their accommodative amplitude. For a myope or a hyperope not wearing their glasses, I want you to take their prescription and just add what it literally is to your converted distance. So we're still working with 10 diopters, and we're just going to add, for this patient, they have a minus 2 prescription. So we're just going to add minus 2, which means we're subtracting 2, which means this patient has uh, an accommodative amplitude of 8 diopters. For the hyperope that has a plus 2 prescription, again, we're going to just add exactly what their prescription is. So we're going to add plus 2, and we're going to end up with 12 diopters as their accommodative amplitude. And then for presbyopes, since they're wearing their prescription, their eye is the same amount as an emmetrope, but their add power is giving them additional power. So with this situation, we're going to ignore the prescription. So this patient is a plus 4 with a 250 add. It doesn't matter what the prescription is. We're just going to ignore that, and we're just going to subtract the add from our distance. So again, 10 diopters, and this time we're going to subtract 2.5, and we're going to be left with 7.5 as this patient's accommodative amplitude. Okay, so we'll do one problem. You're performing Donders, and the patient's first sustained blur is at these distances, and they're wearing a plus 150. They're a plus 150 hyperope. So, and they're not wearing their glasses. So first, we're going to convert everything to diopters. So 12 centimeters is 8.33 diopters, 11 is 9.09, and 10 is 10 diopters. And then we're going to just add their literal prescription to this. So we're going to add plus 150, and that equals 9.83. And then we're going to add plus 150 equals 10.59, and then plus 150 equals 11.5. So the OU amount is just 11.5. We'll leave it at that. This one, 10.59, will round to 10.5. And then with this 9.83, I want you to remember that we are only working with half diopters. So whenever we have a number that's not like a whole or a half diopter, we're just going to round to the nearest half diopter. So in this case, we're going to round to 10. And that's our answer. And there's just one more thing I wanted to cover with rounding. So let's say you had a situation where you ended with 9.24. We would just round that to the nearest half diopter, which is 9. If you had 9.26, you round to the nearest half diopter, which is 9.5. But if you had 9.25, which is exactly in the middle, I want you to round down to 9, I think.